Hello, my name is Mohamed Attwa.
And my name is Mohamed ElMahdy.
We are here today to talk to you about our embedded system project for this semester.
The project is a prototype of a car designed for handicapped people.
The idea came for us because handicapped people, they cannot drive a car. So we came up with the idea of the car that can drive itself. Either it has two modes. One mode, it can be driven manually by a wireless joystick. They can use their hands only. And it can be driven automatically to track a line, and future application for this, it can go from a drop point to drop point in a Google map totally by itself, automatically.
Also, it has a nice feature regarding the brakes. The brakes are turned on automatically if the car faces an obstacle, whatever this obstacle is, a human, a car, a truck, a wall, anything in front of it, the car stops by itself.
So we're going to take you in a demonstration and a simulation for our car components and our code.
Today we are introducing our prototype of a car to the handicapped people or handicapped people. This car has two modes. The first mode is the auto mode, in which the car differentiates between this white area and this black line here, and tracks it till the end or till it finds an obstacle in front. The second mode is the manual mode, in which we use this joystick to control the car. It has two modes. We are starting by giving you the first mode, the auto mode, in which the car differentiates the white area from this black line and tracks it till the end. We can restart our calibration. We start by the auto mode. Now we give you the manual mode. We control the car by this joystick. If it sees an obstacle like this, here it stops.
And I'm going to talk to you about the components of our project. In our project, we used 12-volt battery, two Arduinos, one Arduino for transmitting and another one for receiving. The transmitting Arduino is connected to a wireless module. The voltage and the ground of the module is connected to the Arduino. So as the joystick has two options, manual mode, which you can move it and control the car, and the automatic mode by pressing it downwards. So as the receiver Arduino, it's connected to another wireless module for receiving, and we have our H bridge. And the breadboard, and this is our ultrasonic sensor and our advanced line tracker, two motors, and a two-wheeled car to hold our components. Also, we have our sound buzzer and a LED light to indicate whether we are in the manual mode or in the automatic mode.
Our code is divided into two parts, the receiver part and transmitter part. The receiver part, we are starting by explaining the receiver part. In this part we are defining the pins, assigning integers to it to be recognized by our hardware. And we have here our 6 methods of controlling the car. Actually 5 methods for controlling, and the sixth method is for the auto mode. And here we use pin mode to set the pin as an input pin
or an output pin. For this loop, the loop always checks if there is a signal coming from the transmitter Arduino. Here, this is the part which checks if there is a signal coming. We have here, we have to read the signal, we have to read the letter. We have 6 letters that decides what are we gonna do with that signal. If it's T, that means that we pushed the joystick. We for switching from auto to manual and vice versa. Mode 0 is the manual mode. So if the car is already in mode 0, we switch it to mode 1, which is the auto mode, and then we write 1 to the lid, which light it. Else, if the car is already in the manual mode, if the car is already in the auto mode, we switch it to the manual mode and we turn the lid off here. And this is for the manual mode. If the mode equals 0, that means if the car is in the manual mode. We check for this part actually is for the joystick controlling. If the incoming byte is F, that means that we moved the joystick forward. But first we have to check before moving the car forward if the ultrasonic receiver is giving us a true signal, which means that there is no obstacles in front of it. Then we can move forward. We use the method. We'll get to it later. It's implemented below. And then we turn off the buzz if it's already giving an alert for a previous obstacle. We have to turn it off. Else, if the ultrasonic receiver is giving us a false signal, that means that there is already an obstacle in front of the car. We use here the method stop to stop the car, and we alert the user by turning off the buzz, which gives a beeping sound. For the other 4 methods, the backward, left, right, and stop, we don't have to check for the ultrasonic receiver. We just if we received a signal B, L, R, or S, we just directly use the methods backward, left, right, and stop to control the car in different directions or stop it. Here we have this concerns the auto mode. If this but when the car is in auto mode, it's tracking the line by itself, but it has to stop if there is an obstacle in front of it. So we have to check the ultrasonic receiver again. And here there's our backward, forward, left, and right stop methods. That's these methods are operating through the H bridge, controlling the motors, how they rotate, how they move, or they also setting goal to zero stops all motors. And that's it. And for the transmitter, class or code, we here are defining the maximum voltage, the minimum voltage, and we are assigning pins. That's the setup And here it's an infinite loop. It's always checking for the x and y axes of the joystick, the analog joystick, and it operates according to them. Here, if we move the joystick forward, it sends the letter F to the receiver class, and the receiver class operates according to this, according to the letter it has received. FB, that's forward, backwards, left and right. And this is when we push the joystick down, the transmitter writes T to the receiver, which switches modes. And here, if we centered the analog receiver, the analog joystick, sorry, that means that we are stopping the car by sending the letter S. Thank you.